Hello everyone, welcome to today's lesson on the Year 9 Algebra revision notes. Okay, so these are the solutions to notes you've been doing in the last few lessons. Okay, so these are for you to double check what you've done, check your solutions and so on. Okay, so straight into it. First section here, look on expanding brackets. So I'm just going to go ahead and do the answers. Okay, so when we expand the brackets, remember expand means to multiply, doesn't it? So question A, we should just be multiplying the outside by the inside. Okay, so 3 times x gives us 3x. 3 times 5 is 15. So that's the answer there for question A. All right, similar thing then with question B. So expand is to multiply the outsides by the insides. So 4 times y is 4y. 4 times minus 2 is minus 8. So that's our answer there for that one. And for question C, same again. So 5 times 3t is 15t. 5 times by 7 is 35. Okay, so they are the answers you should have got for the first three. I'm going too fast at any point in the video. Remember, you can always pause and press play when you're ready to move on, okay? Right, next set then. So question D, all right, it's still exactly the same thing, but just be careful with our algebra skills now in terms of multiplying. When we do x times by x, remember, that gives us x squared, okay, not 2x. So x times x is x squared. X times by 6 is 6x, okay? Don't be tempted to collect these together now because of the same letter, because x squared and x are not the same term, okay? Moving on then. So question E, similar sort of thing, look. So 3w times by w, okay, well, w times w is w squared. So 3w times w is 3w squared, okay? And then 3w times by minus 2 is minus 6w. And again, we can't collect those terms together. And then here, okay, 2f times by 3f, okay, do the numbers and the letters separately. 2 times 3 we know is 6, f times f is f squared, okay, and then 2f times by g will just be 2fg. Remember, when we times two letters together, it just becomes those two letters next to each other, basically. So 2f times 3f is 6f squared, 2f times by g is 2fg, okay? And then this is now to expand and simplify. So don't get confused by the two brackets. We're literally going to expand this bracket in the same way we've just done, expand this bracket in the same way, and then collect together the terms that are the same, which, remember, that's what simplify means, doesn't it? Collect together the things that are the same. So 3 times by 2x is 6x. 3 times by 4 is 12. And for the next one, we've got 5 times by x, which is 5x. And then 5 times by 2, which is 10, okay? And now we can collect together the terms that are the same. So we've got 6x there, plus another 5x there, all right? And then we've got 12 there, plus another 10 there. And note this, as I always say, there's nothing that I haven't put a box or circle around now. So I've included all the numbers, all the letters, and all the symbols. Okay, so our answer for this one would be 6x plus 5x is 11x, and 12 plus 10 is 22. Okay, so final answer there of 11x plus 22. So I'm going to do the same thing now with question H. Okay, so expand each bracket separately and then collect together the terms afterwards. So 4 times by t is 4t. 4 times by 4 is 16. Then we've got 3 times by 4t, which is 12t. And then 3 times by negative 2. Okay, so remember the signs are different. When we're multiplying, we're going to get a negative answer, aren't we? So 3 times by minus 2 is minus 6. And then we simplify in exactly the same way. So we've expanded. Now we're going to simplify. Okay, so we get 4t plus 12t is 16t, and then 16 minus 6, look, so make sure that you're subtracting 6 from this one now, will give you positive 10, so plus 10. Okay, so that is the first section there on expanding brackets. Okay, moving on then. So for this section now, solving equations containing brackets. So we're still going to be expanding the brackets in exactly the same way, only we then have to solve afterwards as well. So to solve this one, we're going to expand the bracket first and then work from there. So 5 times by x, well, we know that's 5x. 5 times by 3 is 15. The difference this time is that is equal to 55. Okay, so we've expanded the bracket first. Now we're going to solve, which is what the question is asking us to do. Okay, so remember, when we solve an equation, we work backwards until we've figured out what value x must be. Okay, so the first thing we'll do for this one is, because this says plus 15, we want to work backwards, don't we? So we want to do the inverse. So we're going to take 15 away from both sides. All right, so we end up getting 5x equals 55 take away 15 is 40. And then remember that 5x means 5 multiplied by x, isn't it? So the opposite of multiplying is dividing. So we're now going to divide by 5 on both sides to leave us just x, which is what we're trying to get. 40 divided by 5 is 8. Okay, and it's always a good idea to check this answer in the equation that we were given first of all. Okay, so if x is 8, then 8 plus 3 is 11. 5 times by 11 does give you 55, so you know that x equals 8 is the only correct solution. Okay, same sort of thing for this one then, please. So we're going to expand the bracket first and then try and solve. So 2 times 4x is 8x. 2 times minus 7 is minus 14. Okay, that is equal to 10. Now we solve. So this says minus 14. Okay, we're working backwards, so we're doing the inverse. So we're going to add 14 instead. So we get 8x equals 10 plus 14 is 24. 8x means to times by 8. So we're going to divide by 8 instead. We're doing the inverse. So x equals 24 divided by 8 is 3. And let's double check that that's right. Okay, if x is 3, then 4 times by 3 is 12. 12 take away 7 is 5. 2 times by 5 equals 10. So that works. That's definitely the correct solution. Okay, next one, same sort of thing, please. So we're going to expand and then we're going to try and solve. Okay, so we get 10 equals 2 times 4x is 8x. 2 times minus 7 is minus 14. Okay, and then what you should note this, look, is this one says 8x minus 14 equals 10. This one says 10 equals 8x minus 14. Exactly the same thing, just the other way around. I'm quickly just going to write it the other way around. Okay, 8x minus 14 equals 10. All right, that now is exactly the same as this one, isn't it? So we're not going to bother doing all of the workings out. Okay, x must equal 3, isn't it? 8 times 3, same as it was for this one. Okay, so that's the end of section 2, look. Just check on the time. Okay, that's the end of section 2. So section 3 now, solving equations with the unknown on both sides. All right, so what this means is the unknown, so x in our case is what we're trying to find, is on both sides of the equation. Right, so hopefully you remember for this type of question, the first thing we do is we get rid of, which is usually to subtract the smallest x. So we got 9x on this side and 5x on this side. 5x is the smallest, okay, so we're going to get rid of it. So the opposite of 5x is to take away 5x, isn't it? Because that x at the moment is a positive. So just remember, please, now, when we subtract 5x from both sides, it's only going to affect the terms that have got an x in them, okay? So 9x take away 5x now gives us 4x. This minus 3 here, you can't take 5x away from minus 3, so the minus 3 is going to stay the same, okay? Only this term is being affected on this side because that's the one with an x in there. On this side of the equals, look, we've got 5x, but we're subtracting 5x from that, so that gives us 0, and we're just left with 17 then. Okay, so take away the smallest x from both sides, and now we've just got a normal two-step equation that we're going to solve. This says minus 3, so we do the inverse, and we add 3 instead, so we get 4x equals 20, and then we know by now 4x means x times by 4, So we're going to divide by 4 instead. X must equal 5. And again, let's just double check whether this works. Both sides of these need to be equal to each other. Okay, so if x equals 5, 9 times by 5 is 45. Take away 3 is 42. Okay, and then on this side, 5 times by 5 is 25. 25 plus 17 is also 42. So that confirms that that is the correct answer. Same for this side now, look, so we're going to subtract 3x from both sides. 3x is the smallest, okay? So 8x take away 3x will give us 5x. 11 stays the same. And on this side, we're just left with 51, aren't we? Because 3x take away 3x is 0. Now we solve in exactly the same way. This says plus 11. We're going to do the opposite and subtract 11. Okay, so 5x equals 51 minus 11, which is 40. Okay, so if 5x equals 40, we're now going to divide by 5. X equals 8. Let's double check. 8 times 8 is 64. Okay, plus 11 is 75. 3 times 8 is 24. Plus 51 is 75. So they're equal to each other. X equals 8 must be the correct answer. Okay. Just do these two as well now. So, okay, we got x here, 7x here. So we're going to subtract x from both sides. So we end up with 14 equals 6x minus 46. I'm just going to rewrite that now as 6x minus 46 equals 14. That's how we're used to seeing it. Let's get going now with our inverses. So this says minus 46. We're going to add 46 instead. Okay, so we're saying 6x equals 60. So now we divide by 6. X must equal 10. Okay, 10 plus 14 is 24. Then 7 times 10 is 70. Take away 46 is also 24. So that one works. Okay, same for this one. Now you'll notice that this has got a bracket in there. So let's expand the bracket first. Okay, so we get 7y plus 16 on this side. And once we've expanded this bracket, we get 4y plus 22. Now we can do the same as what we've done earlier on. Okay, so we're going to take away the smallest y in this case, because that's what the unknown is. So take away 4y from both sides. We get 3y plus 16 equals 22. Now we solve as normal. The opposite of adding 16 is to subtract. So 3y equals 22, take away 16 is 6. And then 3y means times. We're going to divide. Okay, so 6 divided by 3 is 2. And let's just double check. 7 times by 2 is 14, plus 16 is 30. And then 2 times 2 is 4. Okay, plus 11 is 15. 2 times 15 is also 30. So that works. Okay, so that's the end of section 3 there as well. Remember, if any of that was too fast, pause the video. You can always go back and forth in your own time. Okay, on to the next section then. So substitution into formulae. Okay, so formula is given by t equals 3c plus 7. In question A, c equals 6, work out the value of t. Okay, so all we're doing is we know the c equals 6, we're substituting it into this equation. Okay, so t will equal, remember 3c means 3 times twice c. So now that we know that the c equals 6, all we're doing is 3 times twice 6 and then adding 7 on. Okay, well 3 times by 6 is 18. 18 plus 7 is 25. So when c equals 6, then t equals 25. So pretty straightforward for that one. Okay. On question B now, it says that t equals 34 and it says work out the value of c. So what we're saying is 3 times by c plus 7. That usually gives us t, doesn't it? And we're saying that we already know the t is 34. So we're just working backwards. Okay. We're just solving basically. So the opposite of adding 7 is to subtract, isn't it? So that means that 3 times by c equals 34, take away 7. Okay, so if we take 7 away, that's 27. And then we know the opposite of times by 3 is dividing by 3. So c must equal 9. Okay, so when t equals 34, c equals 9. And that's the only question on that one, all right? So just substitute the numbers in and then work through the question, basically. Okay, moving on then. So factorising. We need to remember now that factorising means to put into a bracket, okay, using factors. So factors are numbers that go into it, remember. Okay, so for question A, all right, we need to look for the highest common factor. We call it a HCF usually, the highest common factor. So we're looking for the biggest number that goes into 3 and also goes into 6, right? Well, hopefully you've all noticed, so that is 3. 3 goes into 3 and 3 goes into 6. That's the biggest number that goes into both. So that common factor goes on the outside of our bracket, okay? Now on the inside of our bracket, because we know when we expand the bracket, we multiply, don't we? All we've got to figure out is what do we need to multiply 3 by to get these two terms, okay? So if we've already got 3, what are we going to multiply it by to make 3x? Obviously that answers x, isn't it? Then for the second term, we've already got 3. What do we multiply 3 by to make 6? That answer is 2. So therefore we factorized that expression there. Okay, same thing for question B now. So the highest common factor is 5. Okay, so 5 goes on the outside of our bracket. 5 multiplied by y will give us 5y, so y must go there. This has to be a negative now, okay, and then 5 multiplied by something to make 15 would be 3, wouldn't it? And because we already know how to expand brackets from the beginning of this video, if you want to check your answers, just expand them quickly, and if you end up with the expression that you started with, then you've done it right. Okay, right, question C now. There's more than one number. Oh no, there's not. Ignore me. Sorry. We're still looking for the highest common factor, aren't we? So we're looking for the biggest number that goes into 14 and also goes into 21. Okay, which is 7. So 7 goes on the outside. Now, if we've already got 7 and we're trying to make 14w, okay, then we need to multiply by 2w, don't we? Because 7 times by 2 gives us 14. Okay, and then times by w as well will give us 14w. That's going to be plus, eh? And if we've already got 7, we multiply 7 by 3 to make 21. So that's our factorized answer there. Moving on then, so more factorizing. So here now, look, what we've got is, there's no common number, okay, because there's not a number in this one. If we want to put a number 1 in front of it, that's fine, but that still doesn't really help us too much. In this one, what we should be noticing is there's a d in both terms, okay? So this time, d is the thing that's common. So d has to go on the outside, all right? Now that we've got d here, what do we multiply that by to make d squared? Well, that would be another d, wouldn't it? And what do we multiply this d by to make 3d? Would just be the number 3. Okay, so sometimes the thing that's common is not always a number. Sometimes it might be a letter. Sometimes it might be both. So question E, similar sort of thing again. Look, we're looking to factorize, so find the highest common factor. Now, there's more than one number that goes into 8 and 12, but we want the biggest number possible. Biggest should be 4. Okay, so 4 multiplied by something to make 8c, that should be 2c, and 4 multiplied by something to make minus 12 should be minus 3. So 4 and then 2c minus 3 in brackets. Okay, and if we have a look at this one now, this is the first one where we've got a common number but also a common x as well. So x is in both terms, so that has to go on the outside. But if we look at the numbers, the number 2 is also common, okay, because we can get 2 in this out of the 4, and 2 goes into 6 as well. So we've got 2x in this term and 2x in this term, so 2x is common, okay? When it comes to us doing the rest now, we've already got 2x, so what are we going to multiply that by to make 4x squared? We'll do the numbers first. 2 times by 2 will make 4, so there has to be a 2 in there, and x times by x will make x squared. Okay. Then on this nth term now, right, we've already got 2x and we're trying to multiply it by something to make 6x. All right. It's only the number 3. It's not 3x, which is quite a common mistake, because that would give us 6x squared, and that's not what we got, is it? So we've already got the 2 and the x. All we've got to do is multiply the 2 by 3, which is why that answer goes there, okay? And the last little section now on factorising again. Okay, so once again in this one, all right, there's a b in both terms, so b has to be one of our factors on the outside, but we can also now look at the numbers. Okay, the highest common factor of 6 and 15 is 3. Now let's work from there. So we've already got 3b and we're trying to make 6ab. Well, it has to be the number 2 to make 6, isn't it? 3 times 2 is 6. And out of the a and the b, we've already got the b, so that must be an a. 3b times 2a is 6ab. Okay, then it's a negative symbol, and 3b multiplied by something to make 15b should just be 5, shouldn't it? 3 times 5 is 15, and then you've got the b on the end as well. And then similar sort of thing now for this one. All right, w is common in both terms. That has to go on the outside. The number 4 is also common in both terms, okay, because 4 goes into 4 and 4 goes into 8. Now we fill the gaps in from there. So if we've already got 4w, sometimes this can be a bit of a trick question. If we've already got 4w, some people don't put anything in here, but there has to be something in here, doesn't there? So 4w times by 1 will give us 4w. So the number 1 goes in there, okay? Then for the next part, we've already got 4w. We're trying to make 8w cubed. So let's do the numbers first. Obviously, this number 4 has to be multiplied by 2 to make 8, doesn't it? And now to make w cubed, remember, w cubed is w multiplied by w multiplied by w. Okay, so we've already got one of those 3 w's. So surely that must mean there's 2 more that go in there. Okay, 4w times 1 is 4w. 4w times by 2w squared will give us 8w cubed. So a little bit more to think about in that one, but that's how we factorise there. Okay, moving on then. So simplifying now using our indices rules. Okay, so the rules that we need to remember are when we multiply, we add the powers. When we divide, we subtract the powers. Okay, so for question A, it is literally going to be x to the power of 16. Okay, because 5 plus 11 gives you 16, doesn't it? For question B, all right, let's do y part first. So it's going to be y to the power of 9 because of adding the powers. But because we've got 2 normal numbers in front now, we can also multiply those. Okay, so 4 times by 5 gives you 20. Y cubed times y6, y to the power of 6, sorry, gives you y to the power of 9. So it's 20y to the power of 9. And then for question C, okay, let's do the numbers and then the indices together. So 6 times by 10 obviously gives us 60. But hopefully you'll notice on this one now, we can't do like x, y to the power of 13 or anything like that, because the base terms have to be the same. So these base terms were both x's, which is why we simplified. These base terms were both y's, which is why we've simplified. Here we can't simplify because they're not the same term. So we just have to write them as they are. Okay, so 60, x to the power of 5, y to the power of 8. That's all we can do. Moving on then, so dividing this time, okay, so remember when we divide now, we subtract the powers as long as the bases are the same. So for question D, it should just be x to the power of 8. 11 minus 3 is 8, isn't it? For question E, right, y to the power of 2, so y squared. This y on its own, okay, even though there's no power on there, it means to the power of 1. So 3 take away 1 gives us a 2, doesn't it? And then on this one, let's do the numbers and the indices separately. So 30 divided by 10 is 3. C to the power of 7 divided by C to the power of 2 is C to the power of 5, because 7 minus 2 gives us 5. Okay. Right, moving on then. So it's 2 sections remaining now just on nth term. So generating sequences using the nth term. This says write down the first 3 terms for the following sequences. Remember, the first 3 terms mean when n equals 1, when n equals 2, and when n equals 3. So all we're doing is substituting the numbers 1, 2, and 3 into the equation or into the rule. So 6n, right, that would be 6 times 1, that gives us 6. 6 times 2 is 12. 6 times 3, sorry, it's 18. So the first 3 terms of that sequence are 6, 12, 18, and so on. For question B, the equation is slightly more complicated, but we're still just substituting these numbers in. So when x equals 1, we'd be doing 4 times 1 take away 1. Okay, that gives us 3. Then when n is 2, 4 times 2 take away 1. Okay, that gives us 7. When n is 3, 4 times 3 take away 1, that gives us 11. Okay, so that sequence, the first 3 terms in that sequence are 3, 7, 11. That's it. Moving on then, similar sort of thing. So substitute n equals 1, 2, and 3 in here. So this would be 9 minus 2 times 1. Okay, well that gives us 7, doesn't it? Then 9 minus 2 times 2 gives us 5. 9 minus 2 times 3, that gives us 3. So the sequence is 7, 5, 3. And then for question D, look, we're doing n squared plus 4. So when n is 1, 1 squared plus 4 is 5. When n is 2, 2 squared is 4. Plus 4 is 8. When n is 3, 3 squared is 9. Plus 4 is 13. Okay, so that is how we would do that one. So we get, we get 5, 8, 13, and then so on. Okay. Okay, next section then. So we now need to find the nth term. So we've got the sequence, and we need to write down what the nth term is. So we need to work out the rule. Okay, so we're working backwards compared to section 7. Right, what we need to do for these questions then is when we find the nth term, we are looking for whether there's a common difference in the numbers. Okay, so if we look at question A, the common difference, hopefully you can see, is that we're adding 5 each time. Okay, so because we're adding 5 each time, our rule has to start with 5n. Okay, so whatever number is going up by, that number goes in front of n. All right, then we can't just say that that's the answer, because remember, the first term in the sequence is when n equals 1. The second is when n equals 2. The third is when n equals 3, and so on. So if n equals 1, is the first number in the sequence, okay, when we do 5 times 1, we don't get the number 6, do we? We get the number 5. So there has to be something else that goes on the end here. All right, so all we're doing now is figuring out how we change from this number 5 in front of the n to the first number in the sequence, which is 6. Well, that's fairly obvious, isn't it? We just add 1. And that will work now for every other term. So if we pick term number 4 as an example, okay, when n equals 4, 5 times by 4 is 20. 20 plus 1 is 21. Okay, so that works for that one. For question B, same sort of thing. Let's see if there's a common difference. There is in this one. We're going up in 3s. Okay, so our rule must start with 3n. Can't just be 3n though, can it? Because 3 times by 1 doesn't give us 1. It gives us 3. So how do we change this number 3 into the number 1? We subtract 2 from it. Let's check that that works with this one when n equals 3. So when n equals 3, 3 times 3 is 9. 9 take away 2 is 7. That's good. That's our rule. Let's have a look at this one now then. So hopefully we can see that we're adding 8 on each time. So our rule must start with 8n. Okay, it can't just be 8n though, because that doesn't give us the 22 that we need as the first term. So 8 times by 1 is obviously 8. So how many more do we need to go from 8 up to 22, sorry. You should notice hopefully that's 14. And let's just double check that where this is the second term in there. So when n equals 2, 8 times 2 is 16. 16 plus 14 is 30. Okay, so find the common difference. That number goes in front of n, and then just figure out what you need to add or subtract from there then. Okay, if we quickly have a look at these two as well now. So what you should notice in question D is there is a common difference. Okay, the difference is 2 each time, but what is happening is we're subtracting 2 each time. Okay, so if we were going up in 2's, the number 2 would go in front of n. This time, because we're going down in 2's, our rule needs to start with minus 2n. Okay, because that is showing that it's going down in 2's. We can't just write 2n, because that would suggest it's going up in 2's, and we can see clearly that it's going down in 2's instead. Okay, from there, we're still doing the same sort of thing now. We need to work out what goes on the end here. So how do we change this minus 2 into 13, which is the first term in the sequence? Use a number line if you need to. Okay, you should have got the answer plus 15. If we're on minus 2, we need to move forward 15 times to get to 13. Okay, and then again, let's just pick another random one. Let's do this one here. When n equals 4, minus 2 times 4, okay, is minus 8. Then minus 8 plus 15 does give you 7. So that one is right. Okay, and then let's have a look at this one as well. So what is happening on this one is we're going from 3 to 6, which is a difference of 3. Then we're going from 6 to 11, well, that's a difference of 5. Then we're going from 11 to 18, that's a difference of 7. So it's a little bit different here and there because we haven't got a common difference. Okay, hopefully you remember though, when there's no common difference, we have to say the rule starts with n squared instead. Okay, so when they're going up by an extra 2 each time, which is what's happening here, it's going to be n squared. Obviously now, it can't just be n squared, can it, because the rule, because remember, this is when n equals 1. 1 squared is 1. Okay, this is when n equals 2, but 2 squared is 4. This is when n equals 3, but 3 squared is 9. This is when n equals 4, but 4 squared is 16. So we are still going to need something to go on the end. Okay, but the way we work that out is compare these numbers I've just written down with the numbers that are in the sequence. So how are we going to change the number 1 into the number 3? How do we change 4 to 6, 9 to 11, 16 to 18? We add 2, don't we? Okay, so that answer should be n squared and then plus 2. All right, so that's the end of the revision notes for algebra. So make sure that you've used these solutions to check what you've done and made any amendments that you need to. Thanks very much for listening, and see you soon.